Ladies and gentlemen, this is going to be very, very interactive, so keep your phones ready. There are a lot of QR codes coming up for you to scan. So, yeah, happy weekend to everybody, first of all. So, since it's the weekend, the topic is NLP, why, for what, when, and how. So, instead of focusing on the things, the technical things, I mean, they are also included, of course, but I think we look at it NLP wrong. Like, if, for example, if I'm a student and I have heard that, hey, all these AI things are coming from NLP, then I will just look at NLP syllabus. I will start with tokenization, lemmatization, all that. But I think in order to truly excel and understand something, we should think of it in the right way first before diving into the tech things. So hopefully this will work. So yeah, let's get started. So the goals. So let's keep it simple. First, what goes into NLP systems that work well? Second, where and why do they fail? And third, how to improve and achieve whatever we want to do with NLP. So yeah, these are our 3 goals today. So yeah, if you want to look at that agenda, we will go through the quickest machine learning and deep learning recap ever that has been given at an event. Then the second one is the most fun NLP history walkthrough in history of NLP. Wanna bet? And yeah, then we will dive into NLP systems and understanding word representation and language modeling. So let's go. So I would request you to go to Slido and put this code in, and let's kick this off. Just to pick your brain on where do you stand with machine learning and deep learning basics, I thought, why not make it fun? So I will wait a couple minutes if anybody is still joining. There are a lot of people here today. We can see on the screen. Like, it won't feel when you look at the room, but when you see the numbers, then you realize that it is a good attendance. Yeah. Is anybody still joining, or should I start? Okay, let's go. So the first question is, choose the correct statement. AI is part of deep learning and deep learning is part of ML. ML is part of deep learning and deep learning is part of AI. So basically the hierarchy, and deep learning is part of ML and ML is part of AI. What do you think? Which is the correct one? 6 seconds to go. Here come the results. Correct. 57% of our audience got it right. So very proud of you guys. On to the next question. Ashil is leading the leaderboard, followed by Jaival and Heath. Next up, choose the correct statement. Deep learning is part of generative AI. Generative AI is part of deep learning. 5 seconds to go. 3, 2, 2, 1. %73% audience got it right. So that is cool. Okay, the top two stay the same, but third is overthrown by Dhruv. Welcome Dhruv to the leaderboard. And the last one, how old is deep learning? Take a wild guess. Five seconds to go. Alright, 36% got it right. Yeah, it is about 70 years old, imagine that. So, here is the final leaderboard. Congratulations, Javel, Dhruv and Vineet. I do not have any swag for you, but you have my respect. Yeah. Okay. All right. So yeah, most of you got it right. So when we think of AI in an umbrella term, the biggest umbrella is AI, followed by machine learning, and then deep learning, and generative AI is a part of deep learning. Yes. So yeah, quickest recap ever. So machine learning learns from data. We all have established that. What is machine learning? So it is completely based on statistical algorithms and techniques which are used to help learn patterns. And in machine learning, there are two types of learning: supervised and unsupervised. So in supervised learning, the difference is that you have your data and you have labels with it. Imagine a 2-year-old kid. You are teaching that kid that, hey, this is a car, and over and then he or she will start picking it up. Okay, this is a car. Similarly, you feed the model the data and the labels. You teach it over and over again. This is a burger, this is a pizza, this is a French fry, and eventually it will pick it up. So, and the difference in unsupervised learning is that we do not have labels. We just feed the model data, and model tries to figure out which data points are similar to other data points. So you can see that it will eventually figure out that, hey, pizza slices are similar, so let's group them together, and French fries are similar, so let's group that together. So yeah, so that is supervised and unsupervised learning for you. Now coming to deep learning. So how is deep learning different from machine learning? So deep learning algorithms use artificial neural networks. You can see an example there. So this is a model of our neurons in our human brain and how they learn. So this complex network helps neural networks understand complex patterns that might be missed by classic traditional statistical techniques which are found in supervised and unsupervised learning. So I'm not sure many people know this, but so when we talk about deep learning, we're talking about two different kinds. So one is discriminative and the second is generative. So when we talk about discriminative deep learning, then we are talking about prediction or classification. So let's say image classification, cat or dog, all these kinds. So what we are doing, we are trying to discriminate one thing from another. That is why that is called discriminative deep learning. So I'm not sure many people have heard of discriminative deep learning term, so I thought that I should just throw that in. And yeah, discriminative deep learning is typically trained on labeled data, that hey, this is a cat, this is a dog, and the neural network learns based on relationship between data points and labels. So that is about that. And then we come to generative. So as the name suggests, it's trying to generate data from the data it has. That is how it differs from the regular machine learning models as well as discriminative deep learning. So for an instance, learning next word in a sequence, or let's say here is a classic example of discriminative and generative deep learning. I give a model an image of a cat and I ask it to classify, and it gives me, hey, this is a cat. So that is discriminative. It is trying to identify, it is trying to classify. And when I tell a model, hey, generate an image of a cat, and it is giving me the image, then that is a generative deep learning model. So how to tell if a model is generative? So if the output is a number, it is discrete, it is a class, or it is a probability, then it is a discriminative deep learning model. If the output is a natural language, text, image, video, then it is a generative model. So getting that out of the way, it's time to time travel. So this all began, so all the AI chatbots and the roots of NLP began in 1960s and 80s. So what happened? Let's check it out. So we all are aware that AI started with the release of paper by Alan Turing and his famous Turing test in 1950s. And there he has mentioned about an imitation game. It is also a very famous movie if you want to check it out this weekend. So in this imitation game, what Alan Turing says is, the test is like this. There is a human negotiator, and he doesn't know who is talking to. There are 3-4 people. Some of them are humans, some of them are machines. And if that human negotiator is not able to tell if he misidentifies the machine as a human, then that machine passed the Turing test. So basically, the goal is for chatbots to imitate a human as closely as possible. So let's do our own Turing test. So I'll request you to scan this QR code and let's talk to the very first chatbot ever developed by, it was developed at MIT by Joseph in 1966, and this is literally the first chatbot ever built. So let's see. Is everybody able to see the QR code? Once you scan, then I will also interactively chat with it, and let's see what Eliza has to say. Everybody's in? Okay, let's talk to Eliza. So you can see, even from the user interface, that it is so old. So Eliza was built to imitate a psychotherapist. So let's say if I tell Eliza that, hey Eliza, I am sad, right? Then do you believe it is normal to be sad? So it was, so of course it is not AI, right? But it was the very first chatbot ever built, so it was one of its kind, and it was a very, very huge breakthrough in the history of AI. So what Eliza is doing is, Eliza is trying to find keywords. So sad, anxious, what psychotherapists deal with on a day-to-day basis. And then based on those keywords, she is giving me a reply. And if those keywords, if she does not find these keywords, then what she will do is, the input I give her, she will return it to me in a question format. Tell me more about why you are. So if I give her a very new word like, do I have ADHD or something, and if that is not in her database, then she will ask, tell me more about how you feel or something like that, in order to fool the person that, hey, she's really a person and she knows what she's talking about. So that is the very first chatbot for you. So you can do your own experiment, chat with her, figure it out. Do you want? Of course not. So when she does not know what to do, then she will just ask, tell me more, why are you feeling this way, things like that. So this was the very first chatbot, and it was even featured in this pop culture show Young Sheldon, which is based in that period of time, 60s and 80s. So this is the research paper, if you want to check it out later, which announced the creation of Eliza, a computer program for the study of natural language communication between man and machine. Since it was the very first kind, you can see like man and human and machine interaction. So this was the text that they used to test Eliza out, and you can see here that the research paper highlights that The gross procedure of the program is quite simple. The text is read and inspected for the presence of a keyword. If such a word is found, the sentence is transformed according to a rule associated with the keyword. Or else, she will just make your input into a question and ask you back. So you keep having the conversation with her, thinking that there might be a human on the other end. The next breakthrough was in 1972, and the name of the chatbot was Perry. So Perry was again based on an idea by a psychiatrist, and it was built to simulate a person with schizophrenia. So this chatbot was used to train students of psychiatry at the time, where hey, I have given you this chatbot which is a person with schizophrenia. How do you deal with that? How do you talk to them? Etc. etc. So also it was one of the very first to demo human mimicking capabilities. So if we talk to Perry, it will give very bizarre answers, but to a normal person they are bizarre. But sometimes this is how you have to talk and deal with a person suffering with schizophrenia. So that was another breakthrough. So the next breakthrough after 1972 was in 1988. The name of the bot was 𝐫𝐵. And the speciality of 𝐫𝐵 was to simulate a natural human conversation in an entertaining way. So as the name suggests, it used to give wacky replies which were to entertain the user of 𝐫𝐵. And also this was one of the very first demonstrations of use of natural language processing techniques. Earlier it was just heuristic matching, finding the keywords and giving some predetermined replies. But this was the very first one to use NLP. So let's talk to 𝐫𝐵. A term coming around at the time, which was So after 1988, which was 𝐫𝐵, then the next breakthrough was in 1992. This is a gamified chatbot. So if we talk to Dr. 𝐶, which was created for MS-DOS in 1992, and this was the very first demonstration of fully operated chat program. So you can directly chat to the chatbot, and this was the first of its kind. So this was very advanced, and so you can chat with Dr. 𝐶 yourself. Right? So, but again, you can't call anything AI, but this was the AI in 1992. But the thing is, even today people say that, so recently this news came up that Amazon Fresh uses generative AI for just walkout checkouts. But then it turned out that 1,000 Indians were doing this. They were working from India and monitoring the cameras and finding if there was any anomaly in the checkout. So that was not AI, that was actually Indians. So yeah, you can't call anything AI. But yeah, that was impressive when we talk about involving voice-based program, yes. So then next was in 1995, Alice came out, and actually this was really impressive. You can see that it was 3 times Loebner Prize winner, and Loebner Prize is an award which goes to humanoid talking chatbots. So yeah. So the full form of Alice, as you can see, is Artificial Linguistic Internet Computer Entity, and this was also the inspiration behind the movie Her, if you have watched it. Or again, another weekend recommendation. So yeah, so you can chat with Alice as well. Right, so when you chat with her, you will realize how human-like she is. So that is why 5 years in a row she was, Alice was the Loebner Prize winner. Moving on, now the biggest breakthrough was in 2001 when most of us were born, I'm guessing. So the smart child was in many ways a precursor of Siri. So Why so? Let's check it out. So this is something I really love, this one, chatbot. While it's loading, if you missed the link, here we go. Yeah. So this was a chatbot built for MSN and AOL instant message. So so you can, of course, you can also talk to the bot, as well as it was built for, as you can see, it was built to carry out fun conversations, and also it had data access, so it could get back to you with that as well. So see, this is pretty impressive when you think of 2001. So sure, here is a simple recipe for masala chai, etc., etc. So it had a database to pull that out from, which was again a very big breakthrough. So yeah, you can play games, etc. You can design your characters. So this was pretty cool. So there we go. So that is Smarter Child, and then so then everything. So then we have Siri, Google Assistant, Cortana, Alexa, ChatGPT, you know the history, right? So we saw chatbots, and we saw where it all started and how it grew over time. So what is the other ubiquitous use case that we can observe in the field of AI right now? That is RAGs, right? Any product you talk about, any idea that you discuss, any proof of concept you are working for your client on, it will probably be RAG. So again, newsflash, RAG is also not that new. So in the early 80s, so 80s, that is like 45 years back, so Chat80 came out, and Chat80 is the very first RAG of its own, RAG system, retrieval augmented generation. So for those who are not aware with that term, let me fill you in. So retrieval is, you have a database, you go look at the data based on the question that you are asked, and then you augment the data and you generate a natural language response for the user. So that is the whole process, which is what is most of things based on, any chat-based application. So Chat80 came out, and how many of you are familiar with the Prolog language, which was, yeah. So it was used for interacting with knowledge bases in the past. So this was based on this was coded via Prolog, and it was a natural language system which allowed the user to interrogate a Prolog language base in the domain of, it started with the world of geography. So it had a very extensive world geography database. So you can see here, there is an example. If a user asks, does Afghanistan border China? So this, if you're familiar with the Prolog language, you can see the terms that it is, so this will be the question passed to the system, and this is how it will answer. So this was the very first RAG system ever built, so to say. Then we talk about, then in 2009, so this was 80s, and after a lot of years, 30 years or so, Wolfram Alpha came out, and this is still to date active. Even so, if you are into finding different search-based programs like Google, so Perplexity AI is the one thing that is also very on right now. They are trying to build a search-based system better than Google. It is a startup. It is started by an Indian person, Arvind Srinivas. So even they have an integration for Wolfram Alpha, because this is a really good RAG-based system. So it has knowledge bases for a lot of different fields, including mathematics, science, finance, linguistics, geography, and more. So if we go to Wolfram Alpha, computational knowledge engine, which had compute answers, and it can also generate reports for you based on the structured data that it has. And even the RAG that we are building today is based on structured data. You have a lot of vector databases, and you can also connect it to relational databases as well. So yeah, this is the very first version of Wolfram Alpha. There is also a latest one you can switch to. So you can see, you can ask it questions based on all these technologies, and it is good enough to integrate with the current startup project. So there is it. So with this, we are done time traveling back to present now. So around 2000s is when the statistical revolution came into picture, and then in early 2010s, the rise of deep learning started. So this also has a very interesting history. So the rise of deep learning started with a research paper called AlexNet. So this is one of the papers where the authors, let's say that there is Jeffrey Hinton, there is Ilya Sutskever, so all these people. So Ilya Sutskever is also the co-founder of OpenAI. So they were kind of the pioneers in the domain of deep learning, and they won this competition, which is organized by Google every year, ImageNet Large Scale Visual Recognition Challenge or something, right? And that was the first model to use deep learning on a large scale and be successful. So they were the first ones to use GPUs and make the processing faster, etc. So this is where it all started, and now to the current time. Boom of pre-training, thank you open source. So now what we are trying to do is, we are trying to build one large model to do everything, right? Multimodal data, you can talk to images, you can ask it to describe videos, create videos, one large model to do everything. So benchmarks are saturating faster than ever. If somebody is into AI and NLP technical things, this is a paper you can go back and research on. So a lot of things to take notes on. So if you can see the black line, that represents the human capabilities. That is where humans are operating on. And in 2000s, machines were very behind us. But as you can see, over time in 20 years, now models are surpassing human capabilities much faster. So you can see that these models took a lot of time to reach human capabilities. Same in 2000s, but now you can see it's literally parallel or even exponential. So now after 2020s, most models that come up are surpassing this benchmark, the human capability part. So, but even these systems are old. So now what's new? So if you go to this blog post and this benchmark, I have QR codes for both of them. So you will see now, they are not talking about surpassing human performance. Now we are talking about having emergent performance. So what does emergent performance mean? So emergent performance comes with access to a lot of data. So it is almost dependent on the size of data you have. So so you can see here the model scale. As the model increases, the performance is emergent. Initially it's working, and then when you increase the data, it goes straight up. So that is this feature is called emergent performance, and it is tested on different models like GPT-3, Palm, Lambda, etc. So you can read more about it in this blog post, and I will highly recommend checking this benchmark out called Big Bench. So it is one of the benchmarks based on which all the models are tested on, and all the new research papers are coming out. So the question of the hour, how can I become an NLP expert? I would say you just need to know 4 things. So let's make it very, very simple and clear. You can take an image of this slide. So these are the 4 things you need to know to become an NLP expert. Language modeling fundamentals, training and inference methods, experimental design and evaluation, and advanced training and architecture. So let me summarize what this means. So language modeling covers everything from word representations, word vectors, all these things, right? And all kinds of language models. Then we come to training and inference. So it is fine-tuning and supervised fine-tuning and pre-training, all these things. Then experimental design and evaluation covers RAG-based systems. So all these new architectures come into experimental design. And of course, evaluation covers responsible and explainable AI, all these things. And then we go to advanced training and architecture. And most of us wouldn't need to deal with the 4th part. But if you are looking to build something of your own, then you will need to know these things, that I have a very large language model, how do I fit it into my phone? So our phones have, of course we have AI-based applications, but these models are very, very small. If I want to deploy, so if you're building an IoT device, and if I want to deploy a large language model like Gemini or ChatGPT, how do I do it? So all these research is covered in the 4th part, how to, so the terms are like pruning, quantization, and knowledge distillation. So these are used to reduce the size of the model while not impacting the performance. So all of NLP and everything you need to know is boiled down to these 4 things. So what is NLP anyway? So if I were to give you a definition, it just means 4 things. To deal with human language using machines, or to enable human-machine interaction, even to enable human-human interaction and analyze, understand language. So what does that mean? So this you know, right? It to deal with natural language using machines. So if I'm feeding some like Marathi research paper to ChatGPT, then it's using various kind of technology, it should be able to understand what does it mean and get back to me. So that is one use case. Other is human machine. So question answering chatbots, code generation, text summarization, all these things come under human machine interaction. Then there is human-human. So talk about like, so Meta has this new Ray-Ban glasses, right? Which helps you translate what somebody is saying in an ethnic language real time. So what is that? That is AI enabling human-human interaction. And also spell check and other things. So, and then the last part, analyze and understand language. So all the scientific things come into place here. Syntactical, semantic, analysis and words and impact, ambiguation, etc. So typically, we have established this is how an NLP system looks like. The text input could be text, image, even videos, etc. now. And output could be labels, text in another language, continuation of input, image and text, etc. So tasks could be text classification, translation, language modeling, language analysis, image captioning, a lot of things. So how you should start this weekend if you are looking into getting into NLP? You should start with the old school rule-based NLP system. Unfortunately, we do not have time to do this hands-on right now, analyze some movie review sentiments, but yeah, how a old school rule-based NLP system looks like, you have to do 3 things. Again, let's keep it very simple. Feature extraction, score calculation, and decision function. So score calculation is to quantify confidence of your machine learning model with a particular output. That is score calculation. And a decision function. What kind of logic it is using to give you that output, that is decision function. So in old school NLP, this was the 3-step procedure used for any machine learning task. But the challenges with this were, so you can see I have here like 6 different sentences with a very very less used rare words, right? Like Joe is loquacious nature, or he's quirky demeanor and penchant for eccentricity. Nobody talks like that, and there is a very good chance that your model does not know these words. So these are still till date the challenges that NLP has to deal with. What is the solution? Keep working till we get all of the words possible in the world or in all languages. Of course, that's not a criteria. Maybe we can incorporate external resources where in these situations the model can look into. The second challenge is negation. Let's talk about this scenario, right? I have two sentences, both use negative words. The latest Batman adaptation is not without its flaws, but it still manages to deliver an exhilarating experience filled with suspense and intrigue. So it is a positive sentence that you and I can tell that. And also another is, despite high expectations, the recent Batman film never quite reaches its potential, leaving audiences underwhelmed and craving more excitement. That is a negative statement, but both used negative words. So again, this is a challenge that still models face. So what is the solution? Maybe just disregard all the negative words, ask the model to disregard all the negative words, but yeah, for that we would probably need to do syntactic analysis. Another issue is metaphor and analogy that models struggle with. So you can see here two statements. The Scott's teamwork is tighter than Hitchcock's pants after Thanksgiving dinner. It is a positive statement, but yeah, you can see how models can struggle with this. The paperwork pile on Terry's desk is taller than Boyle's Napoleon complex. That is a negative statement, but it is one place where models struggle. And yeah, other languages. Who can tell me which one is positive and which one is negative? Solution is to just learn Japanese, right? So, so yeah, so there are a lot of problems like this that models struggle with, and yeah, NLP is not solved. Very long way to go. So yeah, I mean, my purpose of this was to just introduce you to NLP in the way that you should be introduced to. And I have a list, I have created a GitHub repository of resources you can refer to actually start studying NLP. So just that, as I said, one of the things was language modeling. So how do you know like what it is to model language, right? So all these things. So let's say that here is an example of Jenga. So here we can say that Jenga is a model of a physics-based representation. If I pull out the bottommost both, let's say, boards or whatever, and the whole Jenga will fall out. And yeah, this model exactly replicates physics because that shows gravitation. So similarly, with same intuition but different event, this is how language modeling works, but we will deal with text, sentence, tokens and symbols. That is the only difference. But yeah, a good model can always predict what happens next given some description of context. That is the definition of modeling something, and that is also applicable in language modeling. Goal of a language model is to estimate the probabilities of next events based on a. So yeah, this is where technical things start, and in order for you to start this, here is a GitHub repo which I will keep updating it as I find resources. Currently there are 3 good courses. One is from Carnegie Mellon University. That is the one I highly recommend you to because it literally covers everything you need to know. And the other 2 are from Stanford. So NLP Denrite has 3 courses right now. And yeah, here is our AI community. We host events, we try to host events monthly. So you can join that too as well. Alright, so here, this is where I will wrap this up. Thank you so much, everybody.